Hi, welcome to clickmyproject.com. Now I'm going to explain a complete demo of my project. Title is Synthesizing Ontology Alignment Method using the MaxSum algorithms. In this project I'm going to mapping two different ontologies files. For this mapping I'm using a model-based synthesis method. Using this method only we can generate a confidence values. Using these confidence values we can mapping these ontologies. In existing systems they use a single method to mapping the ontology, and also they can find only the two ontology submission relations. But using this model based synthesis method we are achieving the generality, optimability, scalability and expandability of the ontologies. This is a complete flow of my project. At first I am going to import a dataset. For this project I am going to import the ontology related datasets. After importing the dataset we can pre-processing it. In pre-processing we can remove the special characters, means a tag and some other symbols. After pre-processing the data we can extract the labels and commands and properties from these data. After extracting these fields we can apply these three methods. One is the VSM methods and another one is a CSR method and another one is a COCLU method. In VSM method we can calculate the cosine similarities of data between the two ontologies. Likewise CSR method we can calculate the semantic meaning for each data in the, that means each values in the two ontologies. Likewise COCLU method we can calculate the dice coefficient similarity between the two data in ontologies. After calculating the ontologies similarities we can calculate the confidence values. Based on this confidence value we can integrate. Integration can be performed using the model based synthesis method. After the result will be integrated we can assume the ontology alignment, that means mapping the ontology. We can generate a relationship, that is submissions or disjoint or equivalence. This is the complete demonstration of my project. At first I am going to run a home file. In this file we need to choose the two ontology file. This is to our inputted file. For you need to click browse. After appearing the file chooser we need to select our dataset. Now I am going to select the second ontology file. After selecting these ontology files, these are the content available in our ontology file. We need to click next. In this frame we are going to find out the class and object property in our first ontology file. For finding the class we need to click class passing. Likewise object passing. After finding the class and object passing we can click next. In this value we can identify the class pair values. For finding the class pair values we need to find the label, command and property for each ontology files. For identifying the label, click label. Likewise a command, likewise property. After finding this need to click next. And likewise the first ontology file, in second ontology file also we need to calculate the class and object properties. For finding the class property click class passing. After finding the class property we need to click object passing. After finding the object passing click next. In this frame we can also calculate the or identifying the class pair value for second ontology file. After identifying the class label list we need to identify the command passing. Likewise property passing, and then click next. In this frame we are going to apply our first method, VSM method, that means vector space model. In this model we need to calculate the label weight, command weight and property weight in our both two ontology files. For calculating the label we click a label weight. After calculating the label weight we need to calculate the command weight and likewise the property weight. After calculating these three weights we need to click next. In this frame we are going to calculate the cosine similarity for vector space models. We can calculate the cosine similarity for both class and object properties in our ontology files. First we need to calculate the class type ontology files. It will take some time to calculate the cosine similarity for each values in our dataset. That means a class. After getting the cosine similarity value for class property, we need to identify the cosine similarity value for object property. For this we need to click object type. And this will also take some time to calculate the cosine similarity value for each object properties in our dataset. After getting the object property cosine similarity, we need to click on next. In this frame we are going to calculate the confidence values for VSM model. At first we need to click a confidence measure. After calculating the confidence value, we need to align these. Now the synthesizing ontology can be aligned. After aligned we need to click next. This is a frame which is used to calculate the CSR model, used to calculate the semantic similarity. At first we need to calculate the class type similarity. After calculating the class property for semantic similarity for CSR model, we need to calculate the object property. After calculating the object property semantic similarity for CSE model, we need to click next. In this frame, we are going to calculate the confidence value for CSR model. After calculated the confidence value, we need to align. The alignment can be done based on these confidence values. Now the ontology can be aligned. Then we click next. In this frame, we are going to calculate the COCLU model for dice coefficient similarity. At first, we need to calculate the class type similarity. That means class of property. After calculating the class property for COCLU model, we need to calculate the object properties for COCLU model. After calculating the object property for COCLU model, we click on next. Now this is a frame we are going to calculate the confidence value for COCLU method. After calculating the confidence value, we need to click the alignment. The alignment can be done based on the confidence values generated by the COCLU model. Now our synthesized ontology can be aligned. And we click on next. Now we are going to apply the model-based synthesis method. First, synthesizing. In model-based synthesis method, we can integrate the above three models and get the results. Now the model-based synthesis methods are calculated. These are all the values generated by the model-based synthesis methods. Now this is a word one and the VSM calculation for these words, and likewise the CSR model and COCLU models, and integrate these three we can calculate the weight values. The weight value is the final result that will be produced by model-based synthesis method. After finding this model-based synthesis method's weighted value, we can mapping these two ontologies. And click for alignment. Now this two ontology mapping relation is submissions. After finding the ontology mapping relations, we need to click on next. Here we can calculate the geometric mean for model-based synthesis method. In geometric mean value, we can calculate the precision, recall and F measures values. Thank you for watching this video.